Alright, we have taken the first 20 elements. We have taken the electronic configuration. Now we are going to take the types of chemical bonding. These types of chemical bonding is going to tell us, is going to show us rather, how the bonding takes place. Alright, we have the first one, which is the electrovalent bonding. I'll call it the ionic bonding. This bonding is the bonding between a metal and a non-metal, like I made mention between magnesium and oxygen. Now, magnesium has 2 electrons to give, while oxygen has 2 electrons to receive. Now, the bonding between these two is an electrovalent bonding, the bonding between a metal and a non-metal. In this type of bonding, electron is being given out. We have what we call a donor and acceptor principle, where the metal will donate its electron to the non-metal and the non-metal will accept its electron. So that's what we call a donor and acceptor principle. Now, with this, with that understanding, we know that magnesium is going to give 2 electrons to oxygen. Now, magnesium will be negatively charged, while the oxygen will be positively charged. Now, it has automatically completed its electron in the atom shell, just like I drew it in the other part. Where magnesium gave 2 electrons to oxygen. Alright, that is for electrovalent bonding. It's the bonding between metal and non-metal, where electron is being donated to the non-metal from a metal. Alright, the next one we are going to talk about is covalent bonding. Covalent bonding. This bonding is quite different from electrovalent bonding. In this bonding, it does not involve a metal or a non-metal. In this type of bonding, what happens is that electrons are being shared. In this bonding, it is characterized with sharing of electrons, in which individual elements are to give out single electrons to form an electron pair. What do I mean? I will show you with this diagram. We have sodium. Sodium. We have sodium to be sodium. So we have hydrogen. Now, sodium has 1 element, hydrogen have 1 element. Now, these have 1 element to give, these have 1 element to receive. Now, remember that hydrogen has only 1 element, and remember that the last shell is always duplet. It is not 8, it's always 2. So it needs 1 element to balance it up. Now, sodium has 1. What happens is that sodium will now share with this to balance it up. Now, we will have what we call, this is what we will have. Now, plus the hydrogen. Now, you will see that they have successfully shared their electron. They brought 1, hydrogen had to bring 1 of his electron, while sodium have to bring 1 of his electron to form a lone pair of electron, which 2 elements will share. So in this bonding, it is characterized by sharing of electron, whereby the individual pairs of individual electrons are being brought by the elements to form a lone pair of electrons. So the next bond we will talk about is coordinate covalent bonding. This is in other words known as dative bonding. This bonding is more like covalent bonding, but there is a difference. If you look at it physically, you will say, it's just the same thing, but there is a difference in this bonding. Alright, in this bonding, the element that is attached to the element that is coming to join, okay, let me just put it this way. We will share electron. They will share the electron in which one will bring 2 and one will bring 1. Now, an element is going to bring out a lone pair of electron. Only one element is going to bring out that electron, and they are going to share it by the 2 elements. What do I mean? Now we have carbon. Carbon is having 6 elements in the 6 electrons in the atom shell. 1, 2. Alright, this is for carbon. Now, carbon has 2 elements. Now, why carbon wants to bond? It's going to bond with other elements. Let me say hydrogen. Carbon needs to bond to hydrogen, but hydrogen only have 1 element, 1 electron at the atom shell. Now, carbon has to give out the 2 elements so that it can bond with hydrogen. Chemically, you say it will not be unstable, but it is stable. Now, that electron there automatically will turn positive, it won't be negative. The only electron that will be functioning is that lone pair that will be coming from the carbon. So here it is characterized by electron sharing, but the difference between covalent and coordinate covalent is the element that will bond will produce to talk about hydrogen bonding. Now this is an intermolecular dipole-dipole bond between hydrogen and other elements like nitrogen. Dipole-dipole bonds. Now hydrogen has the capacity of giving 1 element. Now any other element is going to mix has the capacity to give 1 electron. So hydrogen 1 electron and the other element 1 electron. We have what we call a dipole-dipole attraction, a dipole-dipole bonding between these 2 elements. Like I said, for example, nitrogen and hydrogen. Now, nitrogen, due to the dipole-dipole bonding, we have the capacity of producing what we call amine, NH3. NH3, you have nitrogen having 3 hydrogens around it. Okay. Alright. So, nitrogen. Now, oxygen. Hydrogen will now come here. Hydrogen will now come. Now, in this point, we have 2 hydrogen coming together to form half NH3. Now, this one is H2 and this one is H. So we have NH3. A dipole-dipole bonding between 2 elements. Okay, that is just for hydrogen bonding. It does not, it selects. It has a selective element that it will bond. Hydrogen, hydrogen, nitrogen, hydrogen, oxygen. So mostly they form all these neutral oxides. Okay, that's for hydrogen bonding. The next bonding we are going to talk about is metallic bonding. This bonding is the bonding that exists between metals. The bonding that exists between metals, arranging them in what we call crystal lattices. You see, we look at the metal, you see a metal is strong, rigid, and it has a size. That size is what we call the lattices. It has one called crystal lattices. The reason why that metal is having a shape and a lustrous-like manner is because of the crystal lattices and the bonding that is existing between that metal. This is that shape. Now, in that letter, it is being said that electrons now, let me use this as a metal. This is a metal sheet, a long metal sheet. Now, all these things are positively charged. You have proton. Now, there is an electron that is moving around its sides. Remember, I told you electron is negatively charged. Now, the electron is moving around its sides. Now, that electron makes it capable for it to be an electrolyte. That's why when electric touches an iron, it can electrocute you. Any metal, once electric comes to it, it will electrocute you. The bonding there makes the capacity of the electron to be moving around it while it is in crystal lattices. That's the bonding that exists in metals. It's not in any other, it's just a metal. Okay, the next one we are going to talk about is van der Waals forces. Van der Waals forces. Now, this is a bond that comes between, that makes nitrogen form liquid or solid. Nitrogen turning liquid. Nitrogen is a gas. How can a gas turn liquid or solid? This is the bond that makes it be in that manner. Now, this bond is not stronger like covalent and electrovalent bonding. It's not stronger, but it's a weaker bond. This bonding has the capacity of being broken, but it is needed also in liquefaction of gases. What do you mean in liquefaction of gases? Okay, we have methane. Methane as a gas existing in the atmosphere. Now we want to liquefy methane so that it will be used for cooking. Now that is what we will do. We will use the force called van der Waals force to burn this methane so that it will turn into a liquid. It will form a liquid or a solid, and it can be used for cooking. Also, naphthalene. I don't know whether you've heard about naphthalene, a particular solid that when you heat it, it will turn into gas. It does not change to the juice, just sublime into gas. Now, that particular compound is held by what we call van der Waals forces. These forces, they are weak. Once you put light into it, they turn to gas. That's the reason why once you put light into methane, it turns to gas. Okay, so I think I have covered what we have for today's classes. I think we have covered what we have for today's classes. We started with the first 20 elements, the electronic configuration, which we talked about, the types of chemical bonding, which we said we have in between metals and non-metals, covalent bonding, the bonding whereby electron is being shared by individual electrons, whereby you bring one and I will bring one to form a lone pair of electron. Now we have the coordinate covalent or dative bonding, whereby I only bring the electron whereby we will share. Okay, we have the hydrogen bond, which is a dipole-dipole interactive bonding between hydrogen and other elements. We have metallic bond. This bond is only existing between metals, which I have explained. And the last but not the least, the one van der Waals forces, the force that we used to turn nitrogen gases into liquid or solids. I think I have passed a very big knowledge to you. I would like you to subscribe into this channel once more. Remember, click the like button, share, tell your friends about this channel, and as you do that, you will gain more. Thank you so much.